Thanks for watching. If you find my videos helpful, please like, share, and subscribe. And please look in the description beneath this video for useful links to other videos and resources to help you learn chemistry. For today's video, I'm going to teach you how to answer the question shown here. I invite you to pause the video right now and try this question on your own first, then hit play and I'll show you how to do it. There are potentially more than one possible methods that you could use in order to do a percent yield question. I'm going to show you mine, which I think is the easiest one that I've been able to develop over many years of teaching this subject. First of all, percent yield as an equation is actual yield divided by theoretical yield times 100. What does that mean? Well, the actual yield is the amount of product that you are given in the problem if you're dealing with a problem or question on an exam or a problem set. Or in real life, it's the amount of product that you obtain in your lab. The theoretical value is the amount of product that you should get calculated from your limiting reactant. Now that we have that equation in our minds, the next thing we have to ask whenever we're given a percent yield question is, do I know the limiting reactant? Now, if you're ever given a percent yield question where the problem tells you that one of the reactants is added in excess, then you automatically know that the other reactant, the one that is not in excess, is the limiting reactant. That kind of problem is simpler. For this kind of problem, however, we're given two different amounts of reactants, and we're not told which one is in excess. Therefore, we have to go through a specific process to identify the limiting reactant. The method I've developed for that process is this: BCD. B stands for balance the chemical equation. It's provided to us balanced here, so we're done with that. C is convert everything to moles. Now, I'm not going to go into that in detail. Suffice it to say, we just divide each of these masses by their molecular or atomic weights provided in the question. And if we do this, we end up getting the mole amounts shown right here. So I'm going to erase all of these gram amounts and just replace them with their mole amounts. We're now done then with step C. Now at this point you might think, okay, whichever of these is smaller is a limiting reactant, right? Wrong. Because for some reactions like this one, the amounts of reactants get added in different ratios. So for that we go to step D, which is divide each of your moles of your reactants only by their respective coefficients. Whichever outcome is smaller after you do that is the limiting reactant. So here I have an implied coefficient of 1 next to the magnesium. So if I divide 1.03 by 1, I get 1.03. Here, however, I've got 2 coefficient next to HCl. So I divide 0.9599 by 2 and I get about 0.480. Which of these is smaller? Yeah, it's the 0.480. Therefore, I know that HCl is my limiting reactant. With that done, I'm completely done with the BCD process because it says the smaller answer is the limiting reactant. So I'll cross off all of this extraneous stuff and calculate everything from this point forward from that limiting reactant. That is phase 1, identifying the limiting reactant. In phase 2, we use the limiting reactant amount of moles, which is this number right here, to calculate the theoretical amount of our product mag chloride. Now, just so you know, this number of moles right here, which we calculated from the mass of mag chloride provided in the problem, that's our actual yield, which is going to go in the numerator up here. The theoretical yield of this is all going to come from the amount of moles of limiting reactant HCl. For this, we of course use dimensional analysis. You'll notice unit-wise, moles HCl here in the denominator cancel out moles HCl in the numerator. I can, of course, directly relate moles of HCl to moles of mag chloride here in the same set of parentheses because moles of one thing and moles of another thing can touch. What numbers do I put here? They're the coefficients in the balance equation. 2 moles HCl for every 1 mole mag chloride, because these coefficients really are molecule to molecule or mole to mole ratios. These units here, moles HCl, cancel out these units here. And this tells me, once I take the 0.9599 divided by 2, that the answer 0.480 moles mag chloride is how many moles of mag chloride we should get, theoretically, from this many moles of limiting reactant HCl. That is my theoretical. Now we just place this number and this number in their respective locations in that formula, times it by 100. When we throw that into our calculator, the answer that we end up getting is 64.4%, which lines up with option A.